Hi algebra students, this is our introduction video for our lesson on representing exponential decay, and this is going to be our last lesson in this unit on exponential relationships. The focus of this lesson is going to be everything about graphs of exponential decay. In our last lesson, we talked about if you have a story, how can you write an equation for exponential decay, what do the tables look like. In today's lesson, we're going to be focusing on the graphs. So our story we're going to use is the story here about Heather. We have Heather has some bugs in her garden she wants to get rid of. She tries using a pesticide, which she applies every day. The graph below shows the population of bugs, Y, over time in days, X. Our first question is how many bugs are in the garden before Heather starts using the bug spray? I think this is one you can do on your own using what we've learned in past lessons. So go ahead, pause the video here and try answering number 1. Another way to think about this question is we are trying to figure out what our starting point is. And when I say it like that, it helps us see I want to look for that vertical intercept, which is right here at this point. So at day 0, before she starts using the pesticide, we have a bug population of 81. So my answer for this one would be there are 81 bugs in her garden. And if you were ever asked, how do you know? Because you know we love asking that question, we are looking at our vertical intercept or our y-intercept. Now for our second question, this gets more into this exponential relationship. It's going to ask questions about fractions, which we started working with in our last lesson. It wants to know what fraction of the bugs remain after each application and what fraction is removed. We know at this point that if the relationship is exponential, that means there's a multiplication pattern. And so I've got these points marked for our first 2 days. There's some sort of multiplication happening to get from 81 to 27. We're multiplying by a number, and then that same number from 27 to 9. It's a pattern, right? I also know because this is exponential decay, we're multiplying by something less than 1. So depending on the numbers, maybe it's really obvious to you, but if it's not, we can set this up as an equation. I know I'm doing 81 and I'm multiplying by something. So I'm going to say I'm multiplying by f for the factor. And after I do that, it equals 27. And by writing that like pretty small equation, it helps me see to find that multiplication number, I am going to have to do 27 divided by 81. And if you do that, you get that simplified fraction 1/3. So our pattern here is every single time we're multiplying by 1/3. There are 2 questions in number 2. One is going to be the fraction 1/3. And then we saw this earlier, that there's always a second fraction. So if there's a total of 3 parts, 1/3 is one of my fractions and 2/3 would be the other fraction. Now one of these fractions is going to represent the fraction that remains, and one of these fractions is going to be the fraction that is removed. In order to figure this out, I want to think about what my graph is showing. My graph is showing the population of bugs. So that means this fraction 1/3 is related to how many bugs we have. 1/3 is the fraction of bugs that remains, since that's the fraction I'm using to make my graph. Our other fraction then, 2/3, if 1/3 of the bugs remain, I should say after each application or each day, that means 2/3, that is the fraction that is removed by that pesticide each day. These are similar descriptions to what we did in our last lesson, and we're going to continue to practice these today just with graphs. Once you know these 2 numbers though, once you know that we are starting with 81 bugs and that 1/3 of the bugs are remaining after each day, 2/3 are removed, we are able to do this final question, which is writing an equation. Using what you already know about equations of exponential relationships, go ahead, pause the video here and try to write this equation. Come back to see how you did. To help us write this equation, I rewrote our formula for exponential relationships. Remember, our equations in this class are always going to look like this here. And there are two numbers we need to finish our equation. We have learned that that first number in your equation is always that starting point, your vertical intercept. So I would want to say we are starting with 81 bugs. And then the second number, your B, is your decay factor. It's that number you're multiplying by. So I can see from my graph, every single time we were multiplying by 1/3. We were multiplying by 1/3 because that is the fraction that remains each day. And so our equation is y equals 81 times 1/3 to the x power. In today's lesson, we're going to be doing more practice on this. Practice on writing equations from graphs, but then also, if I give you this equation, can you make the exponential decay graph? You are ready for this lesson. Thanks so much for watching.